Hello everyone. My name is Sourabh. I am the co-founder and CTO of Kusho AI. And today I'm going to talk about practical tips for building AI applications or AI agents using LLMs. At Kusho AI, we have been working on building AI applications and agents for the last 18 months. And during our journey, we have identified a bunch of unique problems that people generally face. And we have also faced those same problems, specifically while building applications using LLMs. And the agenda for today's talk is that we want to educate devs about these problems so that when they are building apps on top of LLMs, they are aware of these problems and also discuss what are the solutions that work for us and the dev tools or tooling that we use to solve these problems. And by sharing this information, we want to save time when devs are building applications on top of LLMs for the first time. The first thing that you will need to solve when you start building apps on top of LLMs is how to handle LLM inconsistencies. If you have some experience building applications using normal APIs, you would have seen that they don't fail that often. While building general applications, you don't really worry about inconsistencies or failures that much. If an API fails, you just let the API fail, and the user, when they refresh their page, you make another API call and it will most probably succeed. But in case of LLMs, this is the first thing that you'll probably need to solve when you're actually building an application, because LLMs have a much higher error rate than your normal APIs. And unless you solve this particular thing, your application will have a terrible UX or user experience. Because in your application, you'll generally use the LLM response somewhere else. And every time the LLM gives you a wrong output, your application will also crash. So, this is the first problem that you should solve while building LLM applications. Now, before we get into how to solve this particular problem, let's first talk about why this even occurs in these specific applications. So, like I mentioned earlier, if you're working with normal APIs, you generally don't worry much about the error rate in like fairly stable APIs. But even the most stable LLMs give you a much higher error rate than your normal APIs. And the reason for this is LLMs are inherently non-deterministic. So what do you mean by that? So if you look at an LLM under the hood, they are essentially statistical machines that produce token after token based on the input prompt and what your tokens have been generated previously. Statistical machines are basically probabilistic. And as soon as you bring probability into software, you're going to get something non-deterministic. Now, what do we mean by non-deterministic? You basically will get a different output for the same input every time you ask LLM for a response. You could, and I'm pretty sure like you would have seen this problem while using all the different chatbots that are available, like ChatGPT or the DeepSeek or Claude chat. You would have noticed that every time you give an input, for the same input, every time you hit retry, you'll get a different output. That's the same thing that will happen with the LLM responses in your applications. You most of the time don't have a lot of control over will you get the exact output or not. Now, because of this particular problem, which is LLMs being non-deterministic, every time you give it an input, you'll not always get the response that you want. For example, if you ask an LLM API to generate JSON, which is a structured output, you might get more fields than what you asked for. Sometimes you might get less fields. Sometimes you might have a bracket missing. Based on what we have seen, if you have the normal stable API, you will see an error rate of something like 0.1%. But if you are working with an LLM, even the most stable, the LLMs which have been here for the longest amount of time, they'll give you an error rate of something like 1 to 5% based on what kind of task you're asking it to perform. And if you're working with chained LLM responses, basically you provide the LLM API with a prompt, you take that response, and then you provide it with another prompt using the response that you got earlier. This is basically your chained LLM responses. You will see that your error rate gets compounded. And this particular thing will probably not have a solution in the LLMs because LLMs, like I mentioned, are inherently non-deterministic. That is how the architecture is. So this is something that needs to be solved in your application. You can't really wait for like LLMs to get better and start providing better responses. They will definitely get better and reduce the error rate. But I think as an application developer, it's your responsibility to take care of this issue within your application as well. So what are your options? The first thing that you should definitely try out is retries and timeouts. Now, these are not new concepts. If you've worked in software development for a while now, you would know what a retry is. Basically, when an API gives you a wrong response, you try it again with some cooldown period or maybe not, depending on how the rate limits are. Retry is basically you make an API call, the API fails, you wait for a while, and then you retry it again. As simple as that. Now, when you are developing general applications, I think retries and timeouts are something that are not the first thing that you would implement because you just go with the assumption that the API response rate is going to be fairly reasonable. They will most of the time work, and like not adding retries and timeouts to your APIs will not really degrade the application performance unless like you are working with very critical applications like something in finance or health where the operation has to finish, in which case you will definitely start with retries and timeouts. But in our general experience, if you're working with normal APIs, you don't really worry about these things. But because LLM APIs specifically have a higher error rate, retries and timeouts are something that need to be implemented from day one. Timeouts, again, I think I don't need to get into this. A timeout is basically you make an API call and you wait for X seconds for the API to return. If it doesn't return in X seconds for whatever reason, you terminate that particular API and you try again. This basically is protection against the server, the API server being down. And so if you don't do this, and if the API takes a minute to respond, your application is also stuck for a minute, and so are your users. So a timeout is basically protection so that if an API doesn't return in like a reasonable amount of time, you cancel that API call and you retry that API again. That's where timeout comes into picture. Cool. So how do you implement this into your application? I would suggest don't write the code for retries and timeouts from scratch because there are a bunch of battle tested libraries available in every language that you can use, and with a few lines of code add these behaviors to your application. So let's look at a few examples. The one that we actually use in production is this one called Tenacity by, it's a Python library, and it allows you to add retry to your functions by simply doing this. You add a decorator which is provided by this particular library. You add it to a function, and this function will be retried whenever there is an exception or error in this particular function. Now, you would ideally want more control over how many retries to do, how long to wait after every retry, and those kind of things. Those all options are present in this library. You can give it stopping conditions where you want to stop after 3 retries, you want to stop after 10 seconds of retrying. You can add a wait time before every retry. You can add a fixed wait time, you can add a random wait time. All these different kinds of behaviors can be added using this library with a few lines of code. If you are working in Python, this is our choice, has been working very well for us in production. This is what we have been using for a very long time, so I would recommend this. If you're working in JS, there is a similar library called Retry, very conveniently, that is available on NPM. Similar type of functionalities, it gives you retries and timeouts. Oh, by the way, Tenacity also has timeout related decorators. It works the same way. If you want to add a timeout to a particular function, you just add that decorator, specify the timeout. Yeah, back to this library. If you are working with a JS application, retry is our choice. The third option is basically a lot of people who are developing LLM applications are using these frameworks, LLM frameworks, to handle API calls, retries, and like a bunch of different things. So the most famous LLM framework which a lot of people are using is LangChain. And if you are working on top of LangChain, LangChain provides you basically some mechanism to retry out of the box. It's called the retry output parser. You can use this to make the LLM calls, and whenever the LLM call fails, this parser will basically handle retry on your behalf by passing the prompt again and also the previous output, so that the LLM API has a better idea that, okay, the last output failed and I'm not supposed to give this response again. So if you're on LangChain, then it's already sorted out for you. You use the retry output parser. All right. So this sorts out how to implement retries and timeouts. The next most common reason for failure or LLM inconsistency is when you're working with structured outputs. So when I say structured output, something like you asked the LLM to generate a JSON or XML, CSV, even list arrays, those kind of things. Whenever you're asking an LLM to generate a structured output, there is a slight chance that there'll be something wrong with that structure. Maybe there are some fields missing, there are extra fields. In case of JSONs, XMLs, there are brackets missing. Might happen. So how do you handle that? The simplest way to do that is to integrate a schema library instead of doing it on your own every time. A schema library could be something like Pydantic, and this is what we use in our production. Pydantic is basically the most commonly used data validation library in Python. And what it does is it allows you to create classes in which you describe the structure of your response. And then you use this particular class to check whether the LLM response fits this particular structure or not. It will check for fields, extra fields or less fields. It will check for data types and a bunch of other options. On Python, just go for Pydantic. It is a tried and tested library, and it will make the data validation part when you're working with structured outputs hassle-free. Similarly, if you're working with NPM, there's something called YUP. Same stuff as Pydantic data validation. You essentially define the shape of your output, and YUP basically uses that shape, which is essentially a class, JS class or a JS object, to check or enforce the structure of your LLM responses. And the idea is to use these data validation libraries along with retries and timeouts. What you basically do is when you make an LLM API call and you get a response, you pass it through Pydantic, whatever data validation library you are using. And if you get an error, you use the retry to basically let the LLM generate that structured output again. Most of the time, you would see that a couple of retries sorts it out. It's not like every API call will fail in the same way. So if, let's say, there are a few things missing in your structured output the first time, when you do a retry, the next time you'll get the correct output. But just as a general advice, if you see that there are particular kind of issues happening again and again, you should mention that instruction in the prompt itself. Because what happens is that when you do retry, an API call which was supposed to take 5 seconds might end up taking 15 to 20 seconds. And it will make your application feel laggy, because at the end of that API call, you're going to provide some output to your users and they're waiting for that output. So if that there are particular kind of problems that are happening again and again, like for example, if you are generating using using an LLM API, and you see that like the LLM is always using single quotes instead of double quotes, which will generally cause issues, you should specify that as an important point in your prompt so that you get the correct output in the first attempt itself. This is just an additional level of check, but the idea is that the first response should itself give you the correct outputs. Anything that is known should be mentioned in the prompt as a special instruction, so that you don't keep retrying and your users are not waiting for an output. One additional option worth one special mention here is the structured output capabilities provided by OpenAI. If you're using GPT models and OpenAI APIs, what you can do is there is a response format field where you can specify a Pydantic class. And the OpenAI APIs themselves will try to enforce the structure. But there's one problem here, which is if you want to switch out the model and use something else like Claude or Grok, then you have basically lost the structured output capabilities, because those are not available right now in other LLM APIs. My suggestion is to just handle the schema enforcing and checking in your application itself, so that like it's easy for you to switch out the models and use different models. That's all for handling LLM inconsistencies. Two main things: retries and timeouts. Use them from the start. If you are working with structured outputs, use a data validation library to check the structure. You see the options here. Any of these are good. The next thing that you should start thinking about is how to implement streaming in your LLM application. Generally, when you develop APIs, you implement normal request response. You get an API call, and the server does some work, and then you return the entire response in one go. In in case of LLMs, what happens is sometimes it might take a long time for the LLM to generate a response. That's where streaming comes into picture. Streaming your responses allow you to start returning partial responses to the client, even when the LLM is not done with the generation. Let's look at why streaming is so important while building LLM applications. Like I mentioned, LLMs might take long time for generation to complete. Now, when your user is using your application, most users are very impatient. You can't ask them to wait for seconds. Like, I'm not even talking about minutes. If you have a 10-second delay in showing the response, you might see a lot of drop off. Um, and like most of the LLMs that you would work with would take 5 to 10 seconds for even the simplest prompts. So, how do you improve the UX and make sure that your users don't drop off? That's where streaming comes into picture. What streaming allows you to do is LLMs generate responses token by token. They'll generate it word by word. And what streaming allows you to do is you don't need to wait for the LLM to generate the entire response or output. What you can do is, as soon as it is done generating a few words, you can send them to the client and start displaying them on the UI or whatever client you're using. In this way, the user doesn't really feel the lag that LLM generation results in. What they see is that as soon as they type out a prompt, immediately they start seeing some response and they can start reading it out. This is a very common pattern in any chat or LLM application that you would have used. As soon as you type something out or you do an action, you start seeing partial results on your UI. That is implemented through streaming. The most common or the most used way to implement streaming is WebSockets. WebSockets allow you to send generated tokens or words in real time. The connection is established between client and the server, and then until the entire generation is completed, or as long as the user is live on the UI, you can just like reuse that connection to keep sending a response as and when it gets generated. This is also a bidirectional communication method. So you can use the same method to get some input from the client also. Now, one drawback of WebSockets is that they need some custom implementation. You can't just take like your simple HTTP REST server and convert it into WebSockets. You'll need to redo your implementation, use new libraries, probably even use a new language. For example, if you are working on Python, Python is not very efficient way for implementing WebSockets. You probably want to move to a different language which handles threads or multiprocessing in a much better way than Python, like Golang or Java or even C++. So generally, WebSocket implementation is a considerable effort. And if all you want to do is stream LLM responses, it probably is not the best way to do it. There is another solution for streaming over HTTP, which is called server-side events, which basically uses your REST server itself. Like basically, if you're on Python and you're using Flask or Fast API, you won't need to do a lot of changes to start streaming using server-side events. Code-wise or implementation-wise, this is a minimal effort. What this essentially does is it will use the same HTTP connection which your REST API call utilizes. But instead of sending the entire response in one shot, you can send the response in chunks, and on your client side, you can receive it in chunks and start displaying. Now, this is a unidirectional flow. It works exactly as a REST API call, but instead of the client waiting for the entire response to come, the client starts showing chunks that have been sent from server using server sent events. Implementation wise, it's very simple. Like you just need to maybe implement the generator if you're using Python, and maybe add a couple of headers. We won't get into specific details because these are things that you can easily Google and find out. But our recommendation, if you want to implement streaming in your application and you already have a REST setup ready on the backend, just go for server side events, much faster implementation, also much easier to implement. WebSockets is a bit heavy, and unless you have a specific use case for WebSockets, I won't recommend going that on that path. Streaming is a good solution if the particular task that an LLM is handling gets over in a few seconds, like 5 to 10 seconds. But if your task is going to take minutes, streaming probably is not a good option. That's where background jobs come into picture. If you have a task which can be done in 5 to 10 seconds, probably use streaming, and it's a good way to start showing an output to the user on client side. But if you have a task which is going to take minutes, it is better to handle it asynchronously instead of synchronously in your backend server. And background jobs help you do that. So, what are these particular use cases where you might want to use background jobs instead of streaming? Think of it this way. Let's say if you are building something like an essay generator and you allow the user to enter essay topics in bulk. So if someone gives you a single essay topic, probably you'll finish the generation in a few seconds and streaming is the way to go. But let's say if someone gives you 100 essay topics for generation, I know that this particular task doesn't matter how fast the LLM is going to take minutes, at least a few minutes. And if you use streaming for this, streaming will do all the work in your backend server. And until this particular task is completed, which is going to be few minutes, your backend server resources are going to get hogged or are going to be tied up in this particular task, which is very inefficient because like your backend server's job is basically take a request, process it in few seconds and send it back to the client. If you start doing things which take minutes, you will see that if you have a lot of concurrent users, your backend server will be busy and it will not be able to handle tasks which take a few seconds, and your APIs will start getting blocked and your application performance will start to degrade. So what's the solution here? The solution is you don't handle long running tasks in backend server synchronously. You handle them in background jobs asynchronously. Basically, when a user gives you a task which is going to take minutes, you log it in a database. A background job will pick that task up. Till then, you basically communicate to the user that okay, this is going to take a few minutes. Once the task is completed, you will get a notification, probably as an email or on Slack. And what you do is you use a background job to pick up the task, process it, and once it's ready, you send out a notification. Easiest way to implement this is cron jobs. Cron jobs have been here for, I don't know, for a very long time. Very easy to implement on any Unix based server, which is probably what will be used in most of production backend servers. All you need to do is set up a cron job, which does the processing, and the cron job runs every few minutes, checks the database if there are any pending tasks. Now, when your user comes to you with a task, you just put it in a DB and mark it as pending. When the cron job wakes up in a few minutes, it will check for any pending tasks and start the processing. And on the UI side, you can probably implement some sort of polling to check if the task is completed or not. And once it is completed, you can display that on the UI. But this is an optional thing. Ideally, if you're using background jobs, you should also separately communicate that the task is completed with the user, because the general idea is that when a task is going to take a few minutes, your users will probably come to your platform, submit that task, and they will move away from your platform. So they're not looking at the UI of your application. So you should probably communicate that the task is completed through an email or a Slack notification, so that the users who have moved away from the UI also know that okay, their generation has been completed. This works very well. Minimal setup, nothing new that you probably need to learn, nothing new that you need to install. For the initial stages of your LLM application, just go for a cron job. What happens is that as your application grows, you'll probably need to scale this. Now, if you run multiple cron jobs, you need to handle which cron job picks up which task. You need to implement some sort of distributed locking, and all those complexities come into picture. Basically, cron jobs are good for the initial stages, but like we also started with cron jobs. We still use cron jobs for some simple tasks, but there will be a stage when you'll need to move away from cron jobs for scalability and for better retrying mechanisms. That's where task queues come into picture. So basically, think of task queues as cron jobs with like more intelligence, where all the task management that needs to be done is handled by the task queue itself. When I say task management on a very high level, what it means is that you submit a task to the task queue. Generally, a task queue is backed by some storage like Redis or some other cache. The task is stored over there. And then the task queue handles basically, a task queue will have a bunch of workers running, and the task queue will then handle how to allocate that work to which worker based on like a bunch of different mechanisms. Like you can have priority queues, you can have a bunch of different retry mechanisms, and all those things. Two good things about using task queues are much easier to scale. In a cron job, if you go from 1 to 2 to 10 cron jobs, you have to handle a bunch of locking related stuff yourself. In task queues, it's already implemented for you. So all you can do is increase the number of workers in a task queue. And if you start getting more tasks or workload, the you can just it's as easy as just changing a number on a dashboard to increase the number of workers. Again, like all the additional handling of race conditions, retries, timeouts, it's already taken care of. All you need to do is provide some configuration. You also get better monitoring with task queues. You Every task queue comes with some sort of monitoring mechanism or dashboard where you can see what are the tasks currently running, how much resources they are eating up, which tasks are failing, start or restart tasks, and all those kind of things. Once you start scaling your application, go for task queues. The task queue that we use in our production is called RQ, which stands for Redis queue. And as the name suggests, it's backed by Redis. And it's a very simple library for queuing and processing background jobs with workers. Very easy setup, hardly takes 15 minutes to set it up. If you already have a Redis, you don't even need to set set up a Redis for RQ. And very simple mechanism for queuing and processing. All you need to do is create a queue, provide it a Redis connection so that it has a place to store the tasks. When you get a task queue enqueue, you can, and this is basically a function which is going to get called in the worker to process your tasks. It's this simple. And you can also provide some arguments for that function. And the worker, for the worker, you just need to start it like this on your command line. And it consumes tasks from Redis and process them. If you want to increase the number of workers, you just start 10 different workers, connect them to the same Redis, and queue will itself handle all the complexities of managing which worker gets what task and all those kind of things. If you're on Python, RQ is the way to go. Celery provides you with similar functionality, but we just found that there were a bunch of things in Celery which we did not really need, and it seemed like an overkill. So we decided to go with RQ, which was much simpler to set up on our end. Prompted what inputs are not working, what models are working, what models are not working, and things like that. If you want an analogy, you can think of evals as unit testing. Think of it as unit testing for your prompts. So this allows you to take a prompt template and individually just test out that template with a bunch of different values. And you can, there are a bunch of reasons why you should ideally use evals with your prompt templates. One, it allows you to just test out the prompts in isolation, which makes it very fast. The same way unit tests are fast because you are just checking one function against different types of inputs. Using prompts, using evals, you will be able to figure out different things like which input works, which input doesn't work, which model works for a particular task, which model does not work. You'll be able to compare costs of different models for different types of inputs, and so on. An additional benefit of using evals is that you can directly integrate them with your CI/CD pipeline, so that you don't need to manually keep checking before every release if your prompts are still working the way they are working. Just like unit tests, you just hook it up to your CI/CD pipeline, and before every commit, after every commit or after every build, you straight up run the evals. And similar to assertions in unit tests, evals also have assertions or checks where you can check the response and specify whether it is as expected or not as expected, and pass or fail an eval. That's how, on a very high level, evals work. We have tried out a bunch of different libraries. The one we like the most is Prompt4. Very easy to set up, simply works using YAML files. Basically, you create a YAML file where you specify your prompt template and you specify a bunch of inputs for that prompt template. And using Prompt4 is an open source tool, so you can just like straight up install it from npm, run it in your CLI, and at the end of the eval, you get a nice graph like this, which will show you for different types of inputs whether the output has passed the condition. It will also allow you to compare different models. And there is some way to compare cost as well. I don't think they have displayed it here, but yeah, cost comparison is also something that you'll get in the same dashboard. And you can start off with the open source version of Prompt4, but they also have a cloud hosted version. So if you want more reliability or don't want to manage your own instance, that option is also available. Before we end this talk, let's do a quick walkthrough of all the different foundational models or foundational model APIs that are available for public use. The reason for doing this is basically this landscape is changing very fast. So the last time you had gone over all the available models, I'm pretty sure that by now the list of models and also their comparisons have changed. Probably the models you thought are not that great have become very good, and so on. So let's do a quick run through of all the available models. What are they good at? What are they not good at? What kind of use cases what kind of use cases work with a particular kind of model? Let's start with the oldest player, OpenAI. OpenAI has three main families of models, which is GPT-4o, 4o Mini, and O1, which are available for public use. I think they've deprecated their 3 and 3.5 models. So these are the models that are available right now. If you don't know what to use, just go with OpenAI. These are the most versatile models. They work very well with wide variety of tasks. Within these models, between 4o and 4o Mini, the difference is mainly the trade-off between cost and latency versus accuracy. So if you have a complex task or something that requires a bit more of reasoning, go for 4o. If you are worried about cost or if you're worried about how fast the response is going to be, go for 4o Mini, but it will basically give you lesser accuracy. O1 is something that I have not tried out. These are supposed to be OpenAI's flagship models, but from what I've heard, these are like fairly new. Before you put it in production, maybe test them out thoroughly. 4o and 4o Mini have been around for a while now, so I think you should not see a lot of problems with them. Also, like reliability wise, as according to us, OpenAI APIs have been the most reliable. So you don't need to worry about downtime or having to handle switching models because this provider is not working. The next provider is Anthropic. I think for a while these guys were working mostly on the chat. The APIs were not publicly available as far as I know. But I think in the last few months, I think that has changed. The APIs are available. You can just directly, and they're completely self-serve. You can just directly go on Anthropic's console and create an API key, load up some credit, and get started with it. If you have any coding related use case, Claude APIs are your best choice. I think as far as coding is concerned, coding as a particular task, Claude works much better than all the other models. which is also why you would have seen that everyone is using Claude with their code editors as well, like Cursor. So yeah, if code is what you want, work with Claude. Next up is Grok, not to be confused with XAI's Grok. So Grok is essentially a company that is building special purpose chips. They call them LPUs for running LLMs, which makes their inference time very low, probably even the inference cost. So if latency is what you're trying to optimize, try out Grok. Grok Cloud, which is their API, which are the LLM APIs, they generally host most of the commonly used open source models. So you have Llama, Mistral, Gemma available. Apart from that, a bunch of other things. Latency wise, they are much faster than all the other model providers. So if you are optimizing for latency and these models work for your particular task, go for it. All right. So AWS mainly works like Grok. They host a lot of open source models and along with that, I think they also have their own models, which we have not tried out yet. But the biggest USP of using AWS Bedrock would be if you're already in the AWS ecosystem and you are worried about your sensitive data getting out of your infra and you don't want to send it to OpenAI or Claude or any other model provider. In that case, Bedrock should be your choice. One good thing is Bedrock also hosts Claude APIs. The limits are lower as far as I know. I think you'll need to talk to the support and get your service quotas increased. But if you are worried about sensitive data and you're okay with Claude, Bedrock should work for you very well. And along with that, they also host Llama and Mistral and a few other APIs, multimodal APIs. Azure is, the last time I checked, Azure is hosting GPT models separately. The hosting which OpenAI does is separate from Azure. And the last time we checked, Azure GPT APIs were a bit more faster than OpenAI. So again, if you want to use OpenAI APIs and you want a slightly better latency, try out Azure, but they'll make you fill a bunch of forms. I think these APIs or these models are not publicly available on Azure for everyone as of now. GCP, I've not tried out. Again, I think the setup was a bit complex. We didn't get a chance to give it a try, but from what we've heard, the developer experience is much better now. So someday we'll give it a try again. But GCP has Gemini. And the the newest kid on the block is DeepSeek. If you are active on Twitter, you would have already heard about DeepSeek's APIs. From the chatter, it seems as if they are at par with ON APIs. Again, haven't tried it out. Give it a try. One concern could be the hosting, which is in China. But definitely give it a try. Probably you might find it to be a good fit for your use case. And one more thing, DeepSeek's models are also open source, so you can host them on your own. And that's all from me. I hope you find the information shared in this talk useful and it speeds up your development process when you're building LLM applications and AI agents. If you have any queries or if you want to talk more about this, drop us an email. You can find our email on Kusho AI's landing page or just send me a message on LinkedIn. Happy to chat about this and go build something awesome.